Hey y'all, today we are making connections between situations, graphs, tables, and equations, putting all the things we've been working on when we're looking at representations of multivariate data together. So let's take a look at a couple examples here. A company sells guided kayaking tours. The cost to rent each kayak is $12, and the company charges an $8 guide fee for a group of any size. Represent the relationship between the number of kayaks rented, K, and the total cost, C, for a group with an equation, a table, and a graph. Okay. Now, when you're doing a problem like this, you can choose to start with any one of these that you want. Okay. You don't have to start with the equation. You don't have to start with the table or the graph. You can interchangeably do all of them. Okay. So, what we're going to start with on this first one is the equation. Okay. And when we go back and look at this problem, it says the cost to rent each kayak. So this word here, each kayak, is $12. Okay. And the company charges an $8 guide fee for a group of any size. So the $8 guide fee happens no matter how many kayaks you use. Okay. So it doesn't matter whether we have one kayak or 12 kayaks. Okay. It is not, that cost is not dependent on anything. So that is your constant. Okay. It's not being multiplied by anything. All right. Then each kayak is $12. Well, if you have one person, you need one kayak, right? And that's going to cost you $12. So $12 for each kayak being used, which means $12 for every person who comes kayaking. Okay, so we're going to take 12 and multiply by the number of kayaks we need. And it does tell us here to use kayaks rented to use K. It tells us to use K as our variable here. Okay, and that amount will equal the total cost for the whole group. Okay, so $12 per kayak, so 12K, plus the $8 guide fee is going to equal the total amount the group will owe altogether. Okay, so that is your equation. 12K plus 8 equals our total cost. Okay, then from here, I can do a table. All right. Well, this table already has your the numbers they want you to use in it: one, two, three, and four kayaks. So if K is 1, we're going to substitute into this equation. 12 times 1 kayak plus 8 is going to equal our total cost. Well, 12 times 1 is 12, plus 8 is going to give me a total cost of $20. Okay. Then 12 times 2 plus 8 equals $32 because 12 times 2 is 24 plus 8 is 32. You'll also notice that your cost goes up by 12 each time because the cost for each one additional kayak is, you guessed it, $12. Okay, so that means this is going to be 44. Okay, and I can check that. 12 times 3 is 36 plus 8 equals, in fact, 44. Okay, and it's going to go up another 1256. And you can check that again. 12 times 4 plus 8 equals 56. All right, and now we have our table, which means we can go ahead and graph it. Okay, so we're going to just plot these numbers. Look, they've got 1, 2, 3, and 4. All right. One kayak costs $20 because you also have to pay the guide fee. Okay. Two kayaks is $32. Okay. Three kayaks was $44. Four kayaks is $56. Okay. And you can see that this creates a straight line. Okay. Actually goes through that point 8, which is the cost for the guide. Okay, but you can see that it is a linear function. It's a straight line. Okay, and it matches our situation there. All right. So number two is very similar to that last one, but this time I'm going to start with my table, creating the table first, in case you're a person who prefers to create a table. All right, a craft vendor sells necklaces and charms. Each necklace costs $9. Each charm costs $4. Represent the relationship between the number of charms bought and the total cost of one necklace. Okay, so we're looking at the cost of one necklace. All right, so what this is saying is you buy the necklace and then you pay for additional cost for each charm you want to put on the necklace. Okay, so if you don't want any charms on your necklace, you'll pay $9, right? Because you're just buying a chain, essentially. Okay. And so because of that, in my head, I'm going to go ahead and include this zero. I'm just going to write it up here because I like to remember that zero charms will still cost me $9 because I'm still buying the chain. Okay, so I like to include that on my table, especially when I start with my tables. Okay, and then each additional charm is going to cost a $4 additional after that. So I'm going to add four. So that's going to be 13. Oops, not 14. $13. Okay. And then four more is going to be $17 and then $21 because it goes up for each additional charm by $4. Okay. And you can see they just add one charm each time. That's why I could add four. If they went up by two, we'd have to go up by eight. Okay. Since they filled that out. All right. Now we know the change for each charm is 4. So I can go back and write my equation now. 4 times however many charms we buy plus the cost of the chain or the necklace itself will give you the total cost of your necklace. Oops. Sorry, charms is supposed to be n. I used the wrong variable there. Okay, 4 times n, the number of charms, plus the $9 fee for the chain, and then equals your total cost. All right, and then again, we can just plot those numbers right on that graph. Okay, so zero, we included that in ours, so we can plot that there if we want. Okay, you don't have to. All right, but I always like to know where that line's going to cross that y-axis. Okay, or in this case, the c-axis. Okay, 113. Okay, and then 217, 321, and 425. Okay, and then we can plot our line so you can see that it is in fact linear. Okay, the more charms you buy, the more your cost is. Okay, so those are some examples here. Here are two more that you can try on your own if you would like. Okay, and then they have a graph down here as well that you can do.